Today we are going to discuss about the periodic law. In 1913, S. Moseley was a scientist who discovered the new property of the elements, and that property is atomic number. As we know, Dobrainer's law of octave, Newland's law of octave, and Mendeleev's periodic table was based on the atomic masses. But Moseley in 1913 discovered the new property of the element, that is atomic number. So due to this new discovery of the property of the element, periodic table is arranged according to the atomic number instead of atomic masses. And he observed that due to atomic number we can determine the position of the elements in a periodic table correctly, because there is no regularity in atomic masses, but there is regularity in atomic number, like hydrogen having atomic number 1, helium having atomic number 2, lithium having atomic number 3, beryllium having atomic number 4. So elements having regularity in their atomic numbers. But if you see the atomic mass of these elements, so you know hydrogen having atomic mass 1, helium having atomic mass 4, lithium having atomic mass 7, beryllium having atomic mass 9. So there is no regularity in atomic masses. So Moseley discovered new property, that is atomic number, and according to this atomic number, modern periodic table is arranged. By the arrangement of elements according to atomic number, periodic law is changed. Before, periodic law was properties of the elements are periodic function of their atomic masses. But when new property of element, that is atomic number, is discovered, periodic law is amended as properties of the elements are periodic function of their atomic number, which means if you are arranging elements on the basis of their atomic number, there is repetition of the properties. Periodic function means there is a regular repetition. As I gave you the example of Sunday, after every 6 days you see Sunday. In the same way, after a regular interval, there is repetition of the properties. So Moseley helped us a lot to arrange the elements in a periodic table correctly on the basis of their atomic numbers. Atomic number is very fundamental property than atomic mass, because there is a fixed regularity as 1, 2, 3, 4. The sequence is very clear, 1, 2, 3, 4, 5, 6, 7. But when you are arranging on the basis of atomic mass, then you can feel there is no regularity. 1, then 4, then 7, then 9, then 10, then 12. So there is no a proper sequence. So you have to arrange elements on the basis of atomic number. And as we know, modern periodic table is arranged elements on the basis of their atomic number. See what is explained in modern periodic table. Here you can see modern periodic table. As we know, modern periodic table is arranged on the basis of atomic number, and atomic number is very fundamental property. So there are two aspects to arrange the elements on the basis of atomic number. 2 points. One is it increases regularly from element to element. It increases regularly from element to element. If I share with you periodic table, here you can see the periodic table. Hydrogen is the first element having atomic number 1, then helium, then lithium, beryllium, then boron. So there is regularity in atomic number, increases regularly from element to element. If you are moving hydrogen to helium, so you can see the number is 1 to 2. When you are moving from helium to lithium, the number is 2, then 3. So there is a proper increase in a number, proper regularity in a modern periodic table. So that's why elements are arranged on the basis of their atomic numbers, not on the basis of their atomic masses. Mendeleev had arranged the elements on the basis of the atomic masses, and there was many mistakes as we have discussed. So the next thing is atomic number is fixed for every element. We have discussed about the isotopes. Isotopes are those elements having same atomic number but different atomic masses. So atomic number is a very fixed value, very fixed property that atomic number is not changed. It remains fixed. But atomic masses change, and when there are different isotopes of a same element, there is change in the number of their atomic mass. So that's why modern periodic table is arranged on the basis of atomic number. So if I try to explain what is the modern periodic table, the modern periodic table is based upon the arrangement of elements according to increasing atomic number. So in exam, if you have to explain what is modern periodic table, so you have to explain this. The modern periodic table is the arrangement of element according to increasing atomic number. In a periodic table, in modern periodic table, there are horizontal rows. From left, this side is left side and this side is right side. So from left to right side, these horizontal rows are called as periods. These horizontal rows are called as periods. From left towards right side. For example, this is the first group, second group, and this is the last 8th group. So from first group to last group, from horizontal row, this is called as periods. While I'm talking about vertical columns, this is the vertical column, top to bottom, top to bottom. This is called as vertical column. Vertical columns are called as groups. Vertical columns in a periodic table, in a modern periodic table, are called as groups. Horizontal rows are periods, vertical rows are groups. So, properties of elements were found repeating after regular interval such that elements of similar properties and similar configuration are placed in the same group. Elements, those are in a same group having similar properties because they having similar configuration. Their electronic configuration is similar. The elements of group 1 having one electron in their outermost shell. So, which shows they having same electronic configuration. If I try to draw the structure of hydrogen, here you can see hydrogen having atomic number 1. So, first shell of hydrogen contain 1 electron. If I try to draw the structure of lithium, you can see here lithium having 3 electrons. So first shell contains 2 electrons and second shell contains 1 electron. So you can see hydrogen having 1 electron in its valence shell, in its outermost shell. Lithium having 1 electron in its valence shell, in its outermost shell. If you will draw the structure of sodium, potassium, rubidium, cesium, francium, you will observe that their outermost shell contains 1 electrons. So that's why this group is named as group 1, because they having 1 electron in their outermost shell, and chemical properties depend upon the electronic configuration. So their chemical reactions are similar. Next, we having group 2. The elements of group 2 having 2 electrons in their outermost shell. If I will draw the structure of beryllium, like here, first shell having 2 electrons because beryllium having atomic number 4. First shell having 2 electrons and second shell having 2 electrons. Total 4 electrons. In the same way, you will draw the structure of magnesium. Magnesium contains 2 electrons in their outermost shell. So in the same way, boron, this is group 3A, having 3 electrons in their outermost shell. So arrangement of element on the basis of their atomic number give you the repetition of their properties. That's why modern periodic table is arranged on the basis of atomic number instead of atomic masses. And elements, those are in a same group having similar properties. Next, we having a topic that is long form of periodic table. Basically, in your screen, this is the long form of periodic table. In a long form of periodic table, there are 118 elements. 92 are naturally occurring, other are formed by the disintegration of the elements. In this long form of periodic table, elements are arranged on the basis of their atomic numbers. And as we know, we do the electronic configuration on the basis of the atomic number. If you remember, the electronic configuration in shells and subshells, if you are doing in electronic configuration and shells, so you write K, L, M, N, O, P. And if you are doing electronic configuration in subshells, so you have to write 1 S2 S2 P in this sequence. So electronic configuration is basically based on the atomic number, and modern periodic table, this long form of periodic table, is arranged on the basis of atomic numbers, because there is a repetition of the property when you are arranging elements on the basis of atomic number. So keep remember this term, because I am repeating it again and again, that modern periodic table is arranged on the basis of atomic number, because there is a repetition of the properties while you are arranging elements on the basis of the atomic number. If you try to arrange elements on the basis of their atomic masses, then there are many demerits, as we have seen in the periodic table of Mendeleev. In a long form of periodic table, same horizontal rows are named as a period, and there is no similarity in the period. Elements in a period having no similarity, because they do not having same electronic configuration. If I will see this period number 2, this is first period, this is second period, third period, fourth, 5 period, 6 period, 7 period. There are total 7 periods and 18 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. These 18 are groups. These 18 groups are divided into 1A to 8A and 1B to 8B. So in these 18 are divided into A and B groups. A and B groups. In A groups, there are 8 groups, and in B groups there are 10 groups. So total are 18. But generally we discuss in a Roman that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Total 18 groups. So if I am talking about this period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. This is a second period. Horizontal row is called as period. So you can see all these elements having different atomic numbers. So if they having different atomic numbers, which means they having different electronic configuration. And while elements having different electronic configuration, they having different chemical properties, because the electrons in their outermost shells are different. And chemical properties of the element, their chemical reaction based on the electrons that are present in their outermost shell. Next, if we are talking about vertical columns, these are vertical columns. These are called as groups. There are 18 groups. So while I'm talking about the vertical columns, as we know, electronic configuration of these elements end at 1 electron in their outermost shell. In a group 2, electronic configuration end at 2 electrons in their outermost shell. Elements of this 3A group having 3 electrons in their outermost shell. Carbon, this is carbon group, 4 electrons in their outermost shell. In nitrogen, there are 5 electrons in their outermost shell. In this oxygen family, there are 6 electrons in their outermost shell. In this halogens, fluorine, chlorine, bromine, iodine, astatine, these group is named as halogens. Halogens having 8 electrons in their outermost shell. Fluorine and chlorine exist as a gases, bromine exists as a liquid, and iodine exists as a solid. While you are going downward, their polarizability increase, their atomic sizes increases. That's why their state of matter changes. 8 group, these are named as noble gases, inert gases. This group is also called as zero group, because they are inert, because they having 8 electrons in their outermost shell. As I told you that octet means atom having 8 electron in their outermost shell and they feel stable. So noble gases having 8 electrons in their outermost shell, that's why they are stable, they are inert, they do not react. So here you have seen that you having 18 groups and elements in a same group having same electronic configuration, and due to the same electronic configuration they having similar properties. Next we are going to discuss about the silent features of long form of periodic table. What are the silent features of long form of periodic table? Let's see. This table, first one is, this table consists of 7 horizontal rows. As we told you before, 7 horizontal rows, and this one is 1, 2, 3, 4, 5, 6, 7. These 7 are horizontal rows called as periods. Second silent feature of long form of periodic table is, first period consists of 2 elements. As we know, first element is hydrogen, second element is helium. So first period of long form of periodic table contains 2 elements. Second and third period, these both periods contain 8 elements. This both period contains 8 elements. So you can count 1, 2, 3, 4, 5, 6, 7, 8. So second and a third period having 8 elements. Next we having fourth and fifth period. Elements of fourth and fifth period having 18 elements. Fourth and fifth period having 18 elements. Next we having period 6 and 7. Period 6 having 32 elements. How you can say this, that this period having 32? Because from this you can see at the bottom here, lanthanide series. We have written some elements at the bottom because these elements do not having the similar properties. That's why I am writing, scientists have written them at the bottom. First element is lanthanum. That's why series name is lanthanide. And in a 7th period, here you can see these elements are written at the bottom. Actinium, first element is actinium, that's why series name is actinide. These two series are written at the bottom because they do not having the similar properties as like the elements of these periods and groups. So that's why 6th period having 32 elements because some of the elements are written at the bottom, and 7th period having 32 elements. But this period is incomplete. You have to show it with the steric because this period is incomplete. Why this period is incomplete? Because scientists think that in the passage of a time, new elements will discover. So when new elements will discover, this will not be 32. That's why this period is called as incomplete period. Next, elements of a period show different properties. As I told you before, elements in a period having different properties and elements in a groups having same properties. There are 18 vertical columns from left to right, and these vertical columns are called as groups. The elements of groups show similar properties. This is the 5th point of the silent feature of long form of periodic table. This is the 5th silent feature of long form of periodic table, that elements in a group having similar chemical property. 6th and the last silent feature of long form of periodic table is that elements are classified into 4 blocks. Now I'm going to show you the blocks. Elements are classified into 4 blocks depending upon the type of the subshell which gets the large electron. Here you can see this is the S block, this is the D block. D block elements are also called as transition elements. This is a D block, this is the P block, and the two series at the bottom is named as F block. Why these groups are divided into different blocks? Because S block element having subshell S. While you are doing the electronic configuration of these two groups elements, you will see their electronic configuration end at S subshell. When you are doing the electronic configuration of these elements of D block, you will see their electronic configuration in subshells and at D block, D subshell. Elements of P block having electronic configuration that ends at P subshell. While you are doing the electronic configuration of F block elements, you will see their electronic configuration end at F subshell. That's why elements are divided in 4 blocks. There are 4 blocks: S, P, D and F. S block is first 2 groups, P block is last 6 groups, and D block in the middle 10 groups, and F blocks are the 2 series, those are at the bottom. This is our today's lesson.